Hi friends, I'm very happy to see you here. I'm Shankar Pandey and this is Dr. USP channel. I host videos on media, communication and research on this channel. Many of you would have seen the popular Bollywood movie Lage Raho Munna Bhai, where the protagonist can answer questions as Mahatma Gandhi because he has read a lot of books on Mahatma Gandhi in a short span of time. Although this is not a correct parallel, the language models or the natural language processing models work on the same principle. These models are trained on vast amount of data so that they can make predictions or even generate content based on the training that they've had. Let us see how ChatGPT works, demystifying the magic of artificial intelligence in this video. GPT stands for Generative Pre-trained Transformer. Transformer is a technology developed by the Google in 2017. So we are all aware of this ChatGPT interface. This is the URL chat.openai.com and it will ask us to log in, and we can log in using our Google credentials. We have to provide the Google password. It provides us, when you're logging in for the first time, this is what it provides you. These conversations are viewed by our AI trainers, etc. So you can ask it questions like what is ChatGPT, and as you can say, instantly it provides human-like responses. You can ask questions of your choice. Let's see what it answers. So it can't predict, but it is giving us general kind of answers. So this kind of explains how language model works. Apart from being trained on massive data sets, ChatGPT also works on the principle of reinforcement learning from human feedback. When ChatGPT does write an essay, what it is essentially doing is just asking over and over again, given the text so far, what should the next word be? And each time adding a word. More precisely, it is adding a token, which could be just a part of a word. So ChatGPT is a type of large language model. LLMs consume vast amounts of text and identify connections between words in the text. The goal is to generate predictions about the likelihood of a word occurring in the text given the context of the surrounding words. Natural language processing (NLP) is a subfield of artificial intelligence that focuses on enabling machines to understand, interpret, and generate natural language. The goal of NLP is to enable computers to understand, interpret, and generate human language in a way that is useful and effective. The first step in NLP is to provide the machine with text data in the form of unstructured text such as sentences or paragraphs or whole documents. The machine then breaks down the text into smaller units called tokens, which could be individual words or even parts of words, and all these tokens are given numbers. The next step is stop word removal. The machine removes stop words, which are common words that do not carry much meaning. They can be ignored without sacrificing the meaning of the sentence. Some of the most common short function words are as, the, is, at, which, on, etc. They occur in abundance and provide no unique information that can be used for classification or clustering. The next step is stemming. It is the process of reducing a word to its base or root form. This is often done to simplify text analysis and improve accuracy by treating variations of a word as a single entity. For example, if we stem the original words walking, walked, walks, etc., we get the stemmed word walk. Lemmatization is a more sophisticated process than stemming, which takes into account the context of the word and attempts to transform it into its base form or lemma. This is useful when dealing with words that have multiple meanings or are used in different contexts. For example, runs, running, ran are all forms of the word run. Therefore, run is the lemma. The next step in NLP is the speech tagging process of identifying the part of speech of each word in a sentence. This is helpful for understanding the context of a word and its relationship to other words in the sentence. For example, Umesh is tagged as NN, likes is tagged as VBZ, read is VB, books is NNS. VBZ stands for verb third person singular. The next step is named entity recognition. It's the process of identifying and extracting named entities in text such as people, places, organizations, and dates. This can be useful for analyzing texts for specific types of information. For example, in the original sentence, USP started the Dr. USP channel in 2021. The extracted named entities are USP, Dr. USP, and 2021. The machine then applies parsing techniques to analyze the grammatical structure of the text and understand the relationships between the different parts of the text. The machine then applies machine learning algorithms to analyze the text and perform tasks such as sentiment analysis, language translation, text summarization, and question answering. In LLMs, we have next token prediction and masked language modeling. Next word prediction is also called language modeling, which is the task of predicting what word comes next. For example, if in the sentence it begins as USP is a, the next word prediction will predict whether the next word would be a teacher, would be a former journalist, would be a content creator, or a PhD supervisor given the context. In masked language modeling, the model is given a sequence of words with the goal of predicting the masked word in the middle. For example, the word could be Umesh, mask, teaching. Instead of mask, we could have promotes, enjoys, or elevates. So next token prediction and masked language modeling are common training tasks for RNNs. So given a text, it can predict the next word or the masked word. Recurrent neural networks have difficulty handling long sequences of text. They use a type of memory called a hidden state, which can only retain information for a limited amount of time. Transformers were first introduced in a 2017 paper by a team at Google to address this problem. It was titled, "Attention is all you need." So this is how the transformer works. The transformer memory overcame the limitations of the RNNs and enabled massive improvements. So for example, if we give the input translate thank you, it goes through a series of encoders and then a series of decoders which provides the output dhanyavad. The GPT models are pre-trained language models that use the transformer architecture for tasks such as text generation, question answering, and language translation. The GPT models are trained on large amounts of text data to learn the underlying patterns and relationships between words in the text, which allows them to generate appropriate text. GPT were released in 2018 first, so GPT-1 had 117 million parameters. GPT-2 was released in 2019, it had 1.5 billion parameters. GPT-3 was a vast improvement in 2020 with 175 billion parameters with 570 GB of web text. ChatGPT is a sibling model to InstructGPT, which is trained to follow instructions in a prompt and provide a detailed response. InstructGPT was released in January 2022 from OpenAI by fine-tuning GPT to follow instructions using human feedback. ChatGPT can remember the conversations that happened earlier and then respond accordingly. So behind the scenes, we assign a unique number or a token to each of the 50,000 or so common words in English. So for example, the has the number 914 and the cat is 3542 in GPT-2. So ChatGPT is a giant neural net with 175 billion weights or knobs. Transformers introduce the notion of attention, and the idea of paying attention more to some parts of the sequence than others is at the root of the ChatGPT. The overall goal is to continue text in a reasonable way based on what it's seen from the training it's had, which consists in looking at billions of pages of text from the web, etc. So at any given point, it's got a certain amount of text, the prompts we give, and its goal is to come up with an appropriate choice for the next token to add. The original input to GPT, as we have seen, is an array of numbers or the vectors of tokens. ChatGPT runs these tokens, which are words or fragments, to produce a new token through the 400 layers of the neural net in GPT-3. For each token that we provide, there are 175 billion calculations done each time. ChatGPT is capable of performing zero-shot learning, which means it can perform a task without being explicitly trained for it. This is a significant improvement over earlier versions of GPT, which required fine-tuning for each task. GPT-3 is also capable of few-shot learnings, which means it can perform a task with very little training data. GPT-3 also has better multilingual capabilities. Thanks for staying along, friends. As always, it was a delight having you here. I'll be back with another video very soon. Till then, have a great time.